And what's the next value? The next value, which is a pointer, is holding the address of this node. So we are actually assigning the address of this node to the front, and when we do that, front will start pointing to the second node in the list. Then again, while front is not null, yes, of course, front is not null. So we get the value of the data, which is 2. We display it on screen, and then we update the front to point to the next node. How do we do that? Again, this statement is very important. So front next means get the address of this next pointer and assign it to the front. And this particular next pointer is holding the address of this node. So the address of this node will be assigned to front, and when we execute that statement, the front will now be pointing to the last node in the list. So again, while front is not null, yes, it is not null. So get the value, 1 will be displayed on screen, and then we update the front to point to the next of the front. The next of the front is this one. So we assign this address, which is null, as you can see from this diagonal cross line. We represent the null pointer with this particular line in graphical notation. So null will be assigned to the front. When we do that, so front is actually pointing to this null pointer. And now we say while front is not null, it is null now. So the condition evaluates to false, because if you replace front with null, null does not equal to null, that's false. So we will not execute the body of the while loop and we'll go out of it. So why did I say that this particular implementation of the print is buggy? The reason is we have moved the front from the first node to the last node, and if now the client called the print member function again, it's not going to print anything because the front has been moved. So the sole purpose in life of the front was to always point to the first node in the list. But unfortunately, we have moved it now, and currently it's pointing to null. So the print member function for the second and the third instance will not print anything. So what to do with it? So again, simple. We are going to create a new pointer, which we call a current, and we'll assign the address of the front to the current. So both current and front at this moment are pointing to the first node in the list, right? Now we say, okay, get the value of the current data. So that means get the value of the node, right? The value of the data of the node to which current is currently pointing to. So we'll get 3, and then we'll update current. Current gets the value current next. That means current next is this one. This is the pointer holding an address of this particular node. So we're assigning actually the address of this node to the current, and current will move to the second node now. Again, we'll get the value 2, and then we'll again say that current should be assigned the value current next. That means get the address of this pointer and assign it to the current, but this particular pointer is holding the address of this node. So now current will be updated, and current is pointing to the last node in the list. We'll get the value of 1, display it on screen, and then again we update the current to point to the next of the current. So the next of the current is this one, which is a null value. And now current is actually pointing to the null value. Now when we say while current is not null, this condition evaluates to false. Because if you replace null with current, so null does not equal to null, false. So we will break out of the loop. So this is the correct implementation, and I'm going to demonstrate in the code in just a moment. So I hope that these two member functions are clear to you, and let's go to the Qt creator and implement our linked list class and implement these two member functions along with the constructor in the data members. So here I'm in Qt creator, and I'm going to create a project, non-Qt project. It's going to be plain C++ application, and I'm going to say linked list implementation. It's using one pointer, because we're going to talk about doubly linked list some lectures later. So I'm going to remove the command line arguments. We don't need them. And I'm going to remove the cout statement as well. Just about the main function, I'm going to create a class. I'm going to call it linked list. And under the private section of this class, I'm going to create a structure. I'm going to call it list node. And it will have two parts, the data part and the pointer to point to the next node. I'm going to give it a constructor. So I'm going to say list node int data. I'm going to initialize it with default value. So if the user does not provide, the data parameter gets the value of 0, and I'm going to say list list node star next, and I'm going to initialize that with the default value of null. That's it, and then I'm going to assign data equals data and this dot next equals next. So that's it for our list node. And now let's create an integer variable called size. The purpose of this variable will be to keep track the current size of the list. So, and now the important thing is to have a pointer which is going to point to the front of the list. So I'm going to create a pointer called front, and the data type of this is going to be the list node because it will store the address of a list node object. So that's it for our private section. Now let's create a public section by typing the public keyword, and I'm gonna format my code, and I'm gonna create a constructor. So I'm gonna say linked list, and I'm gonna provide the body, and then in the body I'm going to say size should be 0. So when we create object of our linked list class, the initial state of the object will be the size is 0, and the front should not be pointing to anything, so we initialize it with null. Right, now let's create our member function called void add front, which is going to take a value and insert that in the node. So I'm going to say, okay, create a new node. So I'm going to say list node star new node, list node, and I'm going to put the value. So we are passing the value for the data parameter to the constructor of the list node, but not the value for the pointer. So can you guess what will happen? Yes, the next pointer will get the default value of null. So we'll create a node, and that node has the value, whatever the value was passed. Now what we want to do is say the new node next should be pointing to the front. We want to change this node to the front of the list, and then we have to say, okay, this node has become the front of the list. And again, size plus plus. Whenever we insert a new value in our list, we have to increment the value of size by 1. Now let's implement our print member function. So I'm going to say print, and then I'm going to create a temporary pointer. Let's create the buggy version first, so that you know that what was the problem. So I'm going to say while front does not equal to null, cout front data, and then update front to point to the next of the front. That's it. So I think our implementation so far is complete. Let's create object of our linked list class. I'm going to call it list.add front. I'm going to say, okay, the first value I want to insert is, let's say 3. List.add front, let's say 2 now. So 2 becomes the front value. List.add front, and now 1 will become the first value of the list. And now if I say list.print, it should print in reverse order, 1, 2, 3, right? Because we are adding to the front of the list. So 3 was added before. After that 2 was added, so 2 become the front, and then 1 become the front. So let's compile and run the program, and here is our output. You can see 1, 2, and 3, right? Now let's call the list print again, because the version of the print is buggy. So I'm going to say list dot print, and it should print the list again. This is the expected behavior, but I don't think it's going to happen. So let's see what happens. And as you can see, the list is printed only once. That's because we moved the front pointer in the first call, and the front at the moment is pointing to null. So the fix for that is to introduce a temporary pointer, let's call it current, and assign the value front. So front and current both are pointing to the first node in the list, and I have to replace the front with current in almost everywhere in this particular member function. And now if we run and compile again, the list should be printed 2 times. And as you can see, 1, 2, 3, and then again 1, 2, 3. So thanks for watching. See you next time.